This is the dual range force sensor. It is used in several of our manuals. It shows up in the physics book, the middle school book, physical science, elementary manual. So it's used across a lot of different curricula. It is essentially a spring scale, and the way it operates is that if you apply maybe a pull to it or a push to it, it's measuring the force that you're applying to the sensor. It's a dual range force, so you have two different settings here. There's a plus or minus 10 newtons and a plus or minus 50 newtons. And the idea is that you can set this for what you think the forces you may have there. So you're adjusting the sensitivity on the scale by simply changing the switch from one to the other there. This hole here is to allow you to attach this to maybe a table clamp, and so you want to mount this up high and attach maybe a spring to it with a mass going up and down. You can do that, or weigh something. There's a nice lab from the math book where you put a cup in there and you put pennies in, and so you're looking at what happens as you add pennies to there. So that's how you might use this. You can mount this to our card and track system, and if you did that, you could maybe remove the hook that comes with it, and you could attach the bumper. And so maybe you're doing a collision experiment and you want it to collide with this and measure what happens with the car as it collides with that. That's what that's for. Let me take that back off and put my hook back on. Now on the other end of the sensor here, I can remove this screw and I can attach the handle that comes with it. So the idea here is that if I want to maybe pull something with the sensor, I can attach this handle and be able to pull it. So I'm going to do this. Put that over there. I have this block of wood, and I'm going to attach the sensor to it so that when I pull the block of wood across the tabletop, I want to measure the force that I'm applying to the block. And so I'm going to try to pull this along with a constant velocity and measure the force as I do that. And the real advantage of using this device, say over using a spring scale to do the same thing, is that the spring scale is going to vary back and forth, and you ask the students to read one of the values, and it's going back and forth there, so you might not be able to see that. And so this will allow me to record it. So essentially it's a recording spring scale. So we're ready to collect data, and it is an analog sensor, and so I'm going to plug it into the LabQuest. And when I do this, it auto-detects the sensor, and we come up here with the meter screen, and it's giving me a current reading. It's saying right now that I've got maybe about 0.27 newtons there. And so what's happening is I'm actually applying a little bit of force to the sensor. If I push back just a hair so the string is not pulling on it, then we see that that drops down. Now, one thing about this sensor is that you're going to want to zero it in the orientation that you plan to use the sensor. And what I mean by that is that the sensor is going to give me different values depending upon the orientation. If I hang it this way, then the weight hanging down there is going to change it. If I go this way, then it may change. And so zeroing the sensor allows it to read 0 before I start to doing this. So to do that, I'm just going to go to the meter, and I tap on the meter, and right at the very top it says 0, and so now I press 0 and I'm getting close to a 0 value there. So what I want to do next is drag the block across the tabletop, and I want to be collecting the data as I do this. And so I'm going to move the block over here just a little bit, and now I'm ready to collect. And the default collection is 10 seconds here. I think we've got 50 samples per second. And I am going to press collect and then slowly drag this across the tabletop. So if we take a look at our data now, we see that at first I'm not pulling, and then I pull. All of a sudden the block starts to slide, and I'm trying to pull this along with a constant velocity. Now the surface is not all that smooth. There's a little bit of a roughness there, and so it's kind of grabbing and letting go a little bit, and that's what we're measuring here. And what I might be interested in doing is looking at the mean force applied to the block across this time period. So to do this, I'm going to select the region of the graph where I'm actually pulling the block, go to Analyze, and I go down to Statistics, and I'll check the box next to there. And then over there on the left-hand side, it's telling me what the minimum, the maximum, the mean force applied to the block there. And then the mean force for that time period is 0.634 newtons. So that's just a simple experiment you could do. So again, this is a useful sensor to use across the curriculum, so it's definitely a good one to have.